Hello, and welcome to our video tutorial today on Ampscript Loops, created by Pierre Incorporated, a Wonderman company that partners with Salesforce for Marketing Cloud. We'll be demonstrating how to perform a loop using Ampscript by acting out a common use case. By the end of this video, you should be able to create a row set from a string of data or a lookup, understand how to loop through your row set and output data from it, and utilize the lookup functions to retrieve data from a relational table. To get the most out of this tutorial, it's essential that you have a basic knowledge of Ampscript syntax, like how to set and display a variable, a basic knowledge of HTML, and a basic understanding of Salesforce Marketing Cloud features. For additional reference on Ampscript, please visit developer.salesforce.com. Once there, search for Ampscript and choose the first result. You'll find documentation on every function we'll talk about today, as well as additional examples and use cases. First, let's set up our use case for this tutorial. My client wants to send an abandoned cart email, and their data team has informed me that they will pass records over to us via API as individual rows that will contain a field called SKU. In that field, they will have up to 10 SKU numbers strung together with a pipe character in between. The marketing team wants to have information about each product, including its description and price in the email, so the client has set up a relational table where they provide information about each product based on its SKU number, and it's refreshed every hour using an automation. They have instructed us not to show a product in the email if the SKU number provided isn't in the relational table. Now let's talk about the objects involved in the use case. Inside the Marketing Cloud, we have one data extension set up that contains the information about the products, named Product Feed. In it, the primary key is set to the SKU field, meaning that there can only be one row per unique SKU number. Then we have fields for name, description, and price. Next, we have the data extension that the client will use to place the subscriber information via API, called Abandoned Cart. We have some standard columns for subscriber information, and then a column for SKU, which is set as a text field. For our tutorial, we've already uploaded a set of test records into this data extension, so we can validate our scripts. In our test data, we have included SKU numbers that we know won't be in the product feed, so that we can show that the product does not display when encountered. Okay, we're ready to begin writing our Ampscript. So I've created a basic layout email in HTML, in which we want to create a new table for each product that gets displayed in our loop. As a starting point, we've got one dummy table created with placeholder data. We'll write our script around this table, and then replace the dummy data with Ampscript variables later. You can see here that we're going to want this table to be duplicated in the HTML for every SKU number that we receive. Let's start our Ampscript before this table. I'm going to include an Ampscript comment on each line so that we can always identify what's going on. So in order to loop through data, we first need the data contained within a row set. You can build row sets from lookups, stored XML, or in our case, from a string of data contained in our data extension. The first thing we need to do is create a variable for our string of SKU numbers. For reference, I'm going to put the customer data set on the top right of the screen. Set SKU string equals SKU. This encapsulates the string 4655 13457 1457 into a variable called SKUstring. Ampscript has a special function for building row sets from a string of data called buildRowSetFromString. This function has two arguments, one being the string data source, and two being the delimiter used to separate the data, in our case, a pipe. To store our row set as a variable, we will write set SKURS equals buildRowSetFromString, SKUstring, pipe. We named our variable with an RS, so it's easy to recognize as a row set later. So you can see that I referenced SKUstring as my data source, and then told the function that each piece of data within that string is separated by a pipe. Now our row set is created. It lives in the SKURS variable, but cannot be outputted as viewable text. If you want to visualize what it looks like, just think of this as a table with one column and multiple rows. Now that we've got a row set, let's set up our Ampscript to loop through these SKU numbers and output each SKU in the email as its own table. The next line in our script starts the loop. Here's the full statement that we'll break down now. For I equals 1, 2, row count, SKURS, do. It begins with the command for and is followed by a variable that you create, which is going to be the index. You can use any name you want, but for this example, we're going to use I to represent the index variable. Another way to view the index is like a counter for the loop. Every pass through the loop, the index is raised by 1, like a row number. So the next part of our line is to tell the loop where to begin and where to stop. After the equals, declare which row in your row set to begin the loop. Presumably, it will always be 1. And then the word to, followed by where you want the loop to end. In most cases, you'll want the loop to go through the entire row set. So if your row set contains 10 rows, it will loop from 1 to 10. To account for the dynamic nature of the ending number, we're going to use a function to count the number of rows in your row set, and then use that as our ending point. Row count skew rs. So now our statement says to loop from row 1 to however many rows the row count function finds in our skew rs variable, which in our example is 3. The last command in the statement is do, which executes the loop. So now that our loop is executed, the index, I, is equal to 1, the first pass. We're going to leverage this variable to tell another function which row in our row set to pull data from. For this, we need to introduce the row and field functions. Remember that our row set is comprised of 1 column and 5 rows in memory, just like an imaginary Excel table. And now we need to tell the system which row and then which field in that row to grab data from and stuff that into a variable so we can display it in the HTML. I'm going to put a visual representation of our row set on the screen for reference. First, we declare the row as a variable. Set skew row equals row skew rs I. The row function has 2 arguments. The first one is the row set and the second is the row number. This is where we leverage the index variable. So for the row number, we just put our index variable in there, so whatever pass the loop is on, it will insert that number into the argument. Now that we have a row placed in the variable called skew row, let's get the data from the field in that row. The field function has 2 arguments as well, the first being the row that you're looking at, and the next is either the field name or the ordinal position. This is important to note as our row set doesn't include any headers to have a field name, so we must use the ordinal position, which is 1. If we had generated our row set using lookup rows, it would have produced a header row with field names, to which we could have used the name of that field in quotes as the second argument. More on that later as we'll use this as part of our use case further into the example. So to get the value of the field, we now write set skew equals field skew row 1. Notice that we're naming the variable skew, since that is the data we want to grab from the field. Now here's a pro tip. To make our script more efficient, we can combine the row and field functions into one statement like this. Set skew equals field row skew rs I 1. All we are doing is replacing variables in the latter statements with the full Ampscript that creates them in the previous statements. By combining these, we eliminated the statement where we created the row variable, replacing skew row with the Ampscript that created the skew row variable to begin with. So now we have the first skew number. Let's add it to our HTML to output. Now we have to close the loop. To do this, we need to use the command next followed by our index variable. Next I. This sends us back up to the for statement, so the placement of the statement is very important. For example, if you're generating rows using tr for your loop, make sure that your closing tr tag is there before your next statement. You don't want your HTML tags to be unbalanced as a result of the loop. So to illustrate what is happening at the next statement, the index variable I will be equal to 2, and our row function will look at this row in our row set. When the script reaches the next statement again, it will be equal to 3. Let's load our code in a content builder and see the results so far. As you can see, when I select each record in my test data, the skew numbers become their own table in the email. Success! We now need to factor in the relational data from the product feed, so we can provide the description, name, and price for each SKU number in the email. Remember that the primary key for our product feed was the SKU number, and our loop produces a single SKU number on each pass. So it's time to use that SKU number to look up into the product feed and grab all the data for our email. So after we've declared the SKU variable, the next statement we'll use is either the lookup or lookup rows function. The main distinction between these two functions is that lookup will only return one field from one data extension row, and lookup rows will return all rows and fields that match criteria set in the function arguments. Since we know that the SKU number is the primary key for the product field, we could use lookup, but we'd only be able to return one piece of data per statement, and having a bunch of those in succession is inefficient. So we'll use the lookup rows function to be able to grab all the data about that SKU as a row set all at once. And since we now know how to pull apart row sets using row and field, this should be a piece of cake. So we have our SKU number stored as @SKU. So let's use that to create our lookup row statement to create the row set for the product data. Set product rs equals lookup rows, product feed, SKU, @SKU. Let's break down the statement. Lookup rows has 3 required arguments. First, the data extension name you're looking into. Second, the field in that data extension you're going to use as a key comparison. And third, the value or variable to compare it to. The last 2 arguments are known as the where clause. So if I were to read this statement like I was talking to a database, I would be saying, computer, pull all the product data from product feed into a row set where the SKU number is equal to the number contained in my @SKU variable. If SKU wasn't a primary key, or you didn't have the SKU number to compare, you could build out your where clause with additional pairs of data, as long as they were contained in pairs. The where clause can't use logic, so you can't do things like return rows where the price is greater than $5, for example. You can only narrow down the results on specific values. Here's an example. Set product rs equals lookup rows, product feed, category, sports, city, @city. Telling the system to return all rows where the category is sports and the city is equal to whatever stored in the city variable. Let's get back to the row set we just created, product rs, that now houses our product data for the first SKU. I'm going to construct a series of statements that define all the variables for our data. We'll need to reference the product feed data extension so we know what the field names are. You should recognize these combined statements from earlier, but instead of using the index variable I in the row function, I'm using the number 1, since we know that only one row would get returned. Why? Because we're using the primary key, SKU, to perform the lookup. Therefore, since only one row is returned, I'm telling the system to look at row 1. The second part of each statement calls out the specific field in that row I want to grab. This is the opposite of when we did this in our loop, since there was only one column in our row set. But here we have multiple columns in our row set to choose from. And I could use the ordinal position, but instead of trying to figure out what that is, we can just call it by name. The name is going to be whatever the field name is in the product feed data extension. Now that we have our product variables set, we can add them to our HTML for output. We've left out a very important element to our script, and that is to check to see if the lookup to the product feed was successful or not. Meaning, did it actually return any rows of data based on that SKU number? If the SKU number doesn't exist in the product feed, our row functions here will fail, since we're telling it to look at row 1 where there is no row 1. To account for this, and also to satisfy the requirement of the use case of not displaying the table if the SKU is not in the feed, let's add some logic within our script. Once our lookup row statement is executed, it's going to return either a row set with one or more rows on a match, or 0 rows where there's no match. Therefore, we can use the number of rows it returns in the logic on whether to process or skip this SKU. We'll place if-then logic around our block that looks at the number of rows the lookup statement returns using row count. If row count product rs is greater or equal to 1, then else and if. So essentially what we're asking the system to do is look at the number of rows coming back from our lookup, and if it finds at least one row, then proceed with grabbing the data from that row and displaying the HTML. Otherwise, move on, presumably to the next statement and the next SKU. Now it's time to test our scripting. We've loaded in test data into our data extension and loaded our HTML into Content Builder. Let's use the testing feature to render our email against our test data. As you can see, the first record, all the products are showing, stacked in tables on top of each other. The next record contains a SKU number not found in the product feed, and you can see that that product is not displayed in the email. It was skipped. Success! Congratulations, you've successfully incorporated loops, lookups, and basic logic into your email using Ampscript. Thanks for watching. We'd love to know your feedback. Share what you thought of this video tutorial by reaching us at pieriinc.com.